All right. Hi, seventh period. So I just finished spending about 20 minutes recording myself, thinking I was giving the lesson, and I just realized that my mute was on and I wasn't recording. All right. So if I sound a little tired in this video, guys, I apologize, but that's the reason why. Okay. So back to square one. Jesus. Okay. All right. First thing I mentioned was basically I wanted to make a little plug here. Okay, guys, I'm one of the coaches for the UIL science team at Theo High School. It's a team that we just put together. Okay, it's made up of myself, Mr. Campo, and Miss Arctis, who she teaches astronomy. Mr. Campo teaches chemistry and physics. Basically, what UIL science is, it's a competition that centers around chemistry, biology, and physics. Okay, now you guys being mostly sophomores, probably most of you, if not, all of you, haven't taken physics yet. Okay, so if full stop, you're intimidated right now just from the sound of physics, a subject you haven't studied. We're not going to throw a whole bunch at you. I mean, we're gonna set you up for success. Okay, so anyhow, that's what UIL science is. Okay, it centers around those three subjects, and basically it's a team. Okay, so I'd be a coach, Mr. Campo's a coach, Miss Artis is a coach. We haven't set the weekly schedule yet because this team is brand new. Okay, so right now the focus is just on recruitment, getting students to join. Okay, and then basically the way it's going to work is once we have our members, we're going to come up with, well, we already have a little form that you guys would fill out, and it's basically just to help us narrow down a practice schedule. So we could practice anywhere from 1 day a week for 30 minutes to 7 days a week for an hour. It just depends on what works for everyone. Okay. Now, what are the benefits to this? Okay. Well, in the past, as recent as a couple of years ago, we had students not on the UIL science team, but on the UIL math team compete at the state level, okay, and even win, or at least come in second place. Basically, what this gives you the opportunity to get is a scholarship, okay, and we're talking, I think Mr. Campo wrote it here, anywhere from $1,000 to $20,000 based on your performance at the state level, okay. He's laid out some requirements here. Now we can get into this in more detail should you decide to join. But basically, not everyone is obviously going to make it to the state level. So assuming you don't, right? Let's just say you join and you don't have to make it. This still looks really good on your high school transcript. Okay, this is something that's going to stand out. Okay, especially if you go to the regional level and beyond, of course. So just something to think about. I know we're all busy. Some of us are athletes. Some of us are in band. Some of us are in other clubs and other teams for other things already. But this is something that could open up some doors for you. Okay. So just wanted to throw that out there. If you guys think you're interested, if you'd like to know more about it, or if you think that this is something for you, all right, go ahead and send me an email. Okay, and we can set something up. All right, I've already had 3 of my students from my other pre-AP class go ahead and sign up. So again, if you're interested, 7th period, guys, just go ahead and send me an email and we'll get you set up. Okay. All right, so back to the lesson. Okay. All right, so let me go ahead and open up 7th period. All right, guys. So we're going to continue on with naming, okay, but specifically with ionic compounds, okay? Now, before we jump into naming ionic compounds, I just want to remind you all, this Friday, we're going to have a quiz, okay? The review is here, okay? Again, you don't have to turn this in. This isn't an assignment, all right? This is simply for you guys to go ahead and take a look at and practice it. And again, if you'd like me to go ahead and look over what you've done on the quiz, I'd be more than happy to do that. Okay. Now, the second thing I'm going to note, last time, remember I said there was some clear evidence that cheating took place. Look, I know we're doing remote learning. You guys have the internet. at your fingertips while you're at home, it's easy to cheat. It's easy to cheat. I'm not going to deny that at all. Okay. Um, but it's one thing when you look up information and do some research and write some stuff down, and it's a completely different thing to text your friends and see what they got on question 5, question 4, whatever. That's what I got the last time around. Okay, it was clear. I could tell immediately who knew their stuff and who was providing their answers, because those of you who tried changing the answers up did such a janky job with it that, I mean, it was pathetic, if I'm honest. So again, fair warning. Okay, remember what I said last time, and I'm going to stand by it. If I catch you cheating again, this is your last warning. Okay, I'm going to stand by my word. I will have you removed from this class. Okay, and if you're in a sport or some other club, I'm going to have a conversation with your coach just to let him know what's going on. Okay, if you think I'm being a jerk, guys, there's a standard that I have to uphold. Okay, and that's just how things are going to play out. All right, so please refrain from doing stuff like that. Okay, if you're having trouble, that's what tutoring's for. Okay, if you can't make tutoring, well, send me an email and I'll go over some stuff with you at a different time. All right. All right. Let's go ahead and jump in then to our notes. Now, like I said, I already actually went through them. Okay, so I don't want to have to go ahead and retype this stuff again. So I'm just going to walk you guys through this briefly. Okay. All right. So here's how this works. Okay. When it comes to naming ionic compounds, first of all, remember in an ionic compound, we have a metal and a non-metal that makes up the compound. Okay. Now the second, here are the main points. These right here, these 3 points right here are basically your bread and butter. Okay, with the exception of transition metals, this is really going to be your main guide for naming ionic compounds. Okay, so when it comes to naming ionic compounds, we always name the metal first. Okay, now when we name the metal, it keeps its full name. Okay, we're not going to add any suffix or prefix to it. It's just simply going to keep its name. Okay, so for example, if we had, let's say we had sodium chloride. Let's see here. We have NaCl, right? Here's our first element. That's our metal. We would simply write sodium, not changing the name at all. Okay. For our non-metal, this guy right here, we're going to add the suffix "ide" to its name. So instead of writing chlorine, we're going to knock that suffix off and replace it with an "ide." So we have chloride. Okay. There are no Greek prefixes. Okay. No mono, no di, tri, or anything else when naming ionic compounds. Okay. So magnesium chloride, we're going to name magnesium, right? It's the metal. It keeps its full name. Right here, we have 2 chloride ions, but we are not going to write dichloride. Okay, we are not going to write di in that word. We're simply going to write chloride just like we did up here. Okay, so that's something to keep in mind. Okay, now these are the 3 basic rules. Down here, we're going to go ahead and take a quick look at transition metals. Okay, for transition metals, it's the same thing, but there's one additional rule we have to take into account. Okay, so first of all, remember that transition metals, remember where they're located. Okay, these guys right here are the transition metals. Okay, this big block right here in the middle, this was our F block, or sorry, our D block, right? When we were doing electron configurations. Remember, we had our S over here, we had our P over here, down here was our F, this was our D block. These guys are our transition metals. Okay, now some of these metals, okay, can form more than one ion. Okay, that is, you can have one iron with an oxidation state of +2 and an iron in a different molecule that might have a different oxidation state might have one of 3. Okay, here's another example. Copper could have an oxidation state of 1 or an oxidation state of 2 or 3. It depends on what it's bonding to. Okay, so we need to have a system that takes into account the different charge on the transition metal. Okay, and there are two ways that we do that. Okay, we have Greek suffixes and Roman numerals. Okay, so starting with our Greek suffixes, we have two endings. Okay, the us ending and the ik ending. All right, here we go right here. Two main points. The us ending indicates the lower oxidation state. The ik ending indicates the higher oxidation state. So right here we have iron 2 plus, iron 3 plus. The iron 2 plus is our iron with the lower oxidation state. So it's going to get this us ending. So we have ferrous. Okay, well, you might be thinking, Mr. Murphy, what the hell is this? Ferrous? Where does that come from? This is iron. Well, look, this is a term given to iron. Okay, it's been around, longer than our grandparents have. Okay, so this is a term, ferrous, that is gonna stick to iron always. Okay, until like we, as humans, stop using it. Okay, and we haven't stopped using it. So, should you hear me refer to iron as ferrous, you need to be aware of what it is I'm referring to. All right. Same thing with ferric. Okay, ferric is still iron, okay, but it has a higher oxidation state. Okay, same thing over here. We have our cuprous ion and our cupric ion. That us ending is telling us we have copper with a lower oxidation state, specifically +1. Cupric tells us we're dealing with a copper of +2. Okay, if you're worried about forgetting that, that's why we have notes. That's why you can come back here during a quiz or an assignment and you can reference this. Okay. All right, down here. So this was the first way. This was the first way we name transition metals. Okay. Now the second and more common way, and the way that I prefer naming them, is with Roman numerals. Okay. This is a lot more simpler too. Okay. Basically, all you do is you write the charge on the ion in Roman numerals. So if your charge is +2, you're going to write iron. There's no space. I want to stress that right now. There's no space between the parenthesis and the N. So it'd be iron, parenthesis, Roman numeral 2, close parentheses. Iron 3 plus, you're going to write the word iron, open parentheses, Roman numeral 3, close parentheses. Same thing over here. Copper 1 plus, you're going to write copper, Roman numeral 1. Copper 2 plus, copper, Roman numeral 2. Okay. Now, the last thing I want to stress right here. Okay. The Roman numeral is the charge. Okay. The charge. It is not the subscript. Okay. So what I mean, oh my God. All right. I guess I can't erase that. What I mean by that is this. Okay. You see this in a word, right? Let's say I give you iron to chloride. Okay. That does not mean you would write this. Okay. No. Okay. That too is the charge. Okay. This iron has a +2 charge. Okay. This chloride right here has a -1 charge, right? So these two would end up making this compound right here, iron Cl2. Okay. Now that's why you have to be careful, because if you think that right there tells you that you have 2 irons, well, your whole compound's going to be screwed up. It's not going to be balanced and it gets messy. Okay. So just be aware of that. The 2 is the charge. It does not tell you how many of that ion you have. Okay. And look, guys, I know I'm being a little dramatic in how serious I am. I recognize we're going to make mistakes. This is the first time you guys are dealing with a system of naming for ionic compounds, right? We've come a long way, guys. We're already naming compounds. There's a lot we've learned this year. So, and I know we're like just speeding over this section, but this isn't going away. And as pre-AP students, I expect you to know how to name, okay? And if you forget, well, you're in luck because you have notes on this, okay? And for the quiz on Friday, yes, you can go ahead and use this page, okay? Last thing I'm going to do, we're going to go ahead and take a look at this assignment, okay? So for this first table, what you guys have to do is you have to go ahead and provide, you're given the names of some ions, okay? Now, what you have to do is write them down. So this is a potassium ion, this is the aluminum ion, calcium, and so on, right? Fluoride, oxide, and so on, okay? Look, some of these, chlorite, chlorate, borate, you haven't dealt with that stuff yet, okay? I'm going to tell you guys right now, there's a lot of ions, okay? Like, they're like a lot, okay? I don't even know, I haven't even memorized a good majority of them, okay? So what you guys have, okay, if you scroll down in the Google Classroom, under Classroom Resources, also side note, I posted my tutoring Zoom link if you ever want to hop in, is the ion formula chart, okay? Oh, see this? This has all of the ions that we're going to be using in this class, okay? So it's broken up by positive ions in the first page and negative ions on the second page, okay? I want to stress something really quickly here, okay? In this section right here, guys, hold on one second. Let me move this out of my way. All right, I'm going to be honest with you. The formatting on this page isn't the greatest, okay? For instance, right here, that looks like a 2 minus. That looks like a 3 minus. That looks like a 4 minus. It's not, okay? All the elements that fall under this guy right here, 1 negative, carry a -1 charge. Okay, all these guys carry a -1 charge. So don't get confused here. That's not a 2 negative. Okay, that's not a 3 negative. That's not a 4 negative. These all carry a -1 charge. Okay, same thing here. All these guys carry a -2 charge. All these guys carry a -3 charge up here. All these guys are +1. All these guys are +2. I don't know why that's spaced out. All these are +3. All these are +4. Okay. So I guarantee some of you are going to get mixed up. You're going to think that that's 2 negative, 3 negative. Just be aware of that. All right. So I'm going to do some examples here. All right. We have chlorite. This will be the last thing I do, and then the video will wrap up. Okay. So here's chlorite. Okay. ClO2 1-. So we're going to go here and we're going to write ClO2 1-. Okay. Now, this is a polyatomic ion. Okay. There's more than one atom here. Okay. So when we use this guy to make our formulas, things can get a little confusing. I'm going to show you how to name things, how to basically write these formulas. Okay. We're going to go ahead and write aluminum chloride. Okay. We're going to make this formula. Okay. And here's what we're going to do. Aluminum carries a +3 charge, right? Chlorite carries a -1 charge. So this entire ion, ClO2, this whole guy has a -1 charge, okay? It's not just on the oxygen. The whole ion, sorry, I had you guys write it like this, carries a -1 charge. So you have to be aware of that, okay? Now, with that being said, now that we know that, when we name or when we write the formulas for ionic compounds that include a polyatomic ion, here's how we write it. Okay, so we're going to be using aluminum and chlorite. We're going to write aluminum because the metal always goes first. We're not going to write the charge, okay, because remember in ionic compounds, they're neutral. The charges cancel. We're going to write parentheses. ClO2, close parentheses. We're going to write another subscript, this time of 3. Some of you might see why that is right off the bat. Some of you may not, okay? Those of you who get it, you can always pause the video now, get started on the main assignment, because that was really the biggest thing I needed to highlight. Those of you who don't understand what this is about or need me to go over it in greater detail, stick around, okay? We're going to go down here, just where I have more room, okay? So the charge on aluminum was +3, right? The charge on our chlorite was -1, right? Well, I need 3 of these guys. I need 3 chlorites to cancel this +3. Why? Because -1, -1, -1, that gives me a -3 charge. So now we have +3, -3. What's +3, -3? 0. That's what we want, right? We want to cancel the charges. So we end up having to write aluminum, parentheses, ClO2, 3, because we need 3 chlorites, okay, for this to balance out the charge on aluminum. All right, so that's how you balance out polyatomic ions. All right, that's what you're doing in this first table. In this second section right here, you're going to provide the name. Okay, you're going to name the metal and the non-metal first. Right, so in this case, it would be sodium chloride. You're going to do the same thing all the way down. Over here, you're going to write the chemical formula. So you have magnesium oxide. You're going to have to look up the ions on the ion formula chart probably. All right, if you're not sure. All right, so you would scroll down. You'd have to find magnesium. There it is, magnesium 2+. All right, so you know that this is magnesium 2+. Oxide, where's oxide? That guy's, he's a nonmetal. He's going to carry a negative charge right there, O2-. Oxide, O2-. So we have MgO. Voila. Okay, you're going to do that for all of these. Down here, same thing. All right, you have these non-metal ions and these metal ions. You're going to write the charges or the formula for the ion here. All right, and then you're just going to balance it out. All right, this is copper. That's a metal. It's going first. It has a +2 charge. Fluoride carries a -1 charge. I need 2 fluorides to balance out the charge on copper. Voila. You're going to do the same thing. Okay, down here, same thing that we did up on the first page. You just have to write the chemical formula. Okay, and that's it, 7th period. Okay, if you guys have any questions, send me an email. And I will get back to you later today. Okay, hope this made sense. All right, that does it for this video.